For this circuit we need to find the voltage across resistance R, while R being 1 kilo ohms, 10 kilo ohms and 100 kilo ohms. And first what we will do, we have to find the voltage by calculation, and then if a voltmeter is connected, the voltmeter has an internal resistance of 100 kilo ohms. If the voltmeter is connected across this resistance, we have to calculate what will be the measured voltage. So what I will do, first let's do for 1 kilo ohms. So we can apply voltage divider rule to find the voltage. First we will calculate. So voltage, let's say this one, V for 1, that is for 1 kilo ohms, 40 volts divided by 10, 20 plus 1, 10 plus 20 plus 1, this gives us the current times 1. So just applying voltage divider to find the voltage, and using that we get the voltage to be 1.29 volts. Now we want to find the voltage that will be measured by the voltmeter if that voltmeter is connected across it. The voltmeter has a resistance of 100 kilo ohms internal resistance, so that resistance will come in parallel with this resistance. So the equivalent resistance will be, of course, bit less than 1, though not much because the other resistance is very high, 100. So this one, and this is becoming 0.99. So the measured voltage, let's say this one Vm, we measured for 1 kilo ohms, that will be 40 times 0.99 divided by 10 plus 20 plus 0.99, and that one is 1.2778, something like that. So bit less, the measured value will be bit less. Now let's do the same for 10 kilo ohms resistance. If this the value of R is 10 now, so this one becomes 10. So the calculated voltage will now be 10 plus 20 plus 10 here, and then multiplied by 10. So that will be 10 volts, and V10 measured will be 10 ohms will come in parallel with 100 kilo ohms. So the equivalent value will be 100 divided by 10 plus 100. This time it will be bit less than 10, it will be 9.09. That will be the equivalent resistance. So measured voltage will be 40 times 0.909 divided by 10 plus 20 plus 9.09 that will be 9.09. So the measured voltage now will be, if we calculate this, it comes 9.3 volts. So this here the difference is bit more than the difference there was here, percentage difference, and that happened because the resistance is now bit higher. The measured the resistance, the voltage of the across which the resistance across which the voltage is measured, that resistance value is bit higher. It is bit closer to the voltmeter's resistance, though still it's just 1/10 of that resistance, but previously it was 1/100th. So that was almost, the voltmeter resistance was almost negligible, but this time not quite. Now let's do if the R is 100 kilo ohms, that is this one is equal to the resistance of the voltmeter resistance. So if that happens, the calculated voltage will be 40 times 100 divided by 10 plus 20 plus 100. So if we do this, we get 30.77. The calculated voltage, the actual voltage drop will be 30.77. Now if the voltmeter is connected, the voltmeter internal resistance is 100 kilo ohms, that will come in parallel with the 100 kilo ohms of the resistance. So the equivalent will be now half, much less. So the measured value will be now 100 m, sorry, m100, that's how I was writing it, so I don't know how I was writing it. Yeah, m was the subscript, and then sorry, m here, and here it's 100. That means this one will be 40 times 50, because now the resistance is becoming 50. 10 plus 20 plus 50, and this one gives us 25 volts. So we can see that this time the measured voltage, voltage that the voltmeter will measure is much less than the actual voltage. This is 30.77 and this is 5 volts less, and in terms of percentage this is also significant less. So this is how, with a certain amount of certain resistance, voltmeter resistance, if the resistance is not that high, we can't measure a higher if the resistance of which voltage we are measuring has a value of resistance which is comparable with the resistance of the voltmeter, the internal resistance of the voltmeter, then the measured voltage will be erroneous, will have significant error. But if the the resistance is much less than the, like for the first case it was 1/100th of the voltmeter's resistance, so then it was the measured voltage was almost accurate. But if this is comparable, it's not accurate. So this is just an observation. This problem also sheds light on that effect. So yeah, this is just